Welcome back. So today what we're going to do is install some pistons, but first I need to put some frost plugs back in the block, put the oil barbell back in the back of the block before I forget, and then I'm going to set up the ring grinder and I'm going to grind the gap in the top ring and the second ring. Also, I'll double check the oil rings, make sure there's enough clearance on that. I'm also going to use my dial bore gauge and check my rod bearing clearance as well. And if that's all good, I'm going to go ahead and install the pistons today. So we'll start with setting up the piston ring filer. So first things first, I'm going to put some thread sealant on these frost plugs, which go in the block. There's also one on the other side of the motor as well. And these get torqued to 44 foot-pounds. So I'll go ahead, oops. Okay, now if that's done, I'll put the new barbell in the back of the block. So I decided to go with the brand new GM replacement barbell. There are aftermarket ones. I heard some really mixed reviews on the aluminum ones, so this one seems to work fine. So I'm just going back with a brand new stock replacement, putting some assembly lube on it. Get in there. Maybe just a hair more lube on that O-ring. There she goes. Just like that. She's in there so I don't forget it when it comes time to put on the rear cover. So just checking my cylinder bore. First thing I did is I zeroed out my caliper with my gauge, a 4-inch gauge, to make sure it zeroes perfectly at 4 inches, which it does. And then I rotated it to get, so the finished bore on my block should be 4-inch 070. It's 25,000, 50,000, sorry. Yeah, 50,000, 60, 70. And I lock my caliper there. Then what I did is off camera, because this can be tricky to do, I set it up and I zeroed my dial bore gauge again, which I think it needs just a little bit of adjustment here. So I'm zeroing it out at 4.070, and then I'm just going to check the bores. See how close they are from one to the other. Well, it should be good. Check the bores now. So now that I have the dial bore gauge set up for 4.070, I'm just going to have a look at the bore. Now I do realize that this is without a torque plate on, like it was machined with a torque plate, so the measurements are going to be a little bit different here. So I'm just checking kind of out around. Looking at the taper. And there is a big difference between, you know, my $250 bore gauge versus a $2,000 bore gauge for accuracy and measurement. So it's about half a thou. I'd say about 6/10,000ths tighter. So for my gauge, I'm looking 4.069, which would still be over 4/1000ths of an inch piston to wall clearance. So that looks good. I'm gonna go ahead and start sizing up piston rings. So next thing I need to do is start grinding piston rings. So according to Diamond, I contacted them and I got a gap chart for the rings. So my bore is 4.070. I'm going to be running 15 to 30 pounds of boost in that range. So they suggest with E85, the bore times 0.0075, which will give me 0.0305. So 30,000ths of an inch bore, or sorry, top ring gap. Second ring is bore times 0.0065. So that works out to 0.0264, so 26 thou. And then obviously the oil ring needs a minimum of 0.015. So I'm going to set up the grinder and start grinding the top rings. Piston ring grinder is set up for the size of piston rings now. So I just had to adjust the eccentric here. The eccentric stop. And basically what that does is it changes the cutting face angle to make sure that you're not cutting just on leading edge or the tailing edge, that it's cutting completely flush, so that when your rings come together, when they're warm, they're nice and flush. So there's zero gap as of right now. I checked the first top ring in the number 1 cylinder. This is gonna be number 1. I'll have it all laid out and marked. So now that that's set up, I'm gonna go ahead and start taking a little bit at a time and test fitting it in the bore. Okay, so first ring set up. I have it zeroed out, touching the wheel. So I'm gonna start. Wheel has got a few high spots, so I'm just gonna take a little bit at a time till the wheel kind of trues itself. So we'll start here. So it looks like I took about 5 thou off there. So I'll go another 5 and go from there. We'll go check it in the bore and see how much it took off. So I just checked in the bore and basically only took a couple thou off, so I'm gonna reset my ring, re-zero it, and start grinding some more. And I'll just time lapse this because this is gonna take some time. Okay, so first ring is gapped. It's in the bore. Right at 30 thousandths of an inch. That's the top ring. So I'm gonna continue and do all the top rings, and then I'll move to the second ring and then check all the oil rings. So yeah, I'll just time lapse this because this could take a long time too. So next thing I'm going to do is check rod bearing clearance. And you do it the same way as you do your mains. Check your crank diameter. So these should be pretty close to stock. So it looks like I'm just about a thou under. The crank was polished, so they may have polished this just a little too much. So I'm going to set up the dial bore gauge, put a set of bearings in one of the pistons, and check my bearing clearance. So I'm going to set up my dial bore gauge to my journal size again, which I did off camera because it took a little bit. Just confirming the sweep. Could just be about a tenth of a thou adjustment there. Okay, we're good there. So next I'm going to install a bearing and a rod, torque it to spec, check the bolt stretch, make sure I got adequate bolt stretch, and check rod bearing clearance. So I'm going to take a measurement on my rod stretch gauge prior to putting any load on it. Zero it out. So I've pre-assembled these rods before, and I know that with Moly Lube and 75 foot-pounds, it gets me my 6/1000 of an inch bolt stretch that I need, which is what ARP recommends for these ARP 2000s. So just kind of showing you that's at zero. Now I'm going to put a set of bearings in that I've already cleaned, wiped down, torque it up to 75, and check my bolt stretch. Okay, so bearings in, everything's torqued, bolt stretch is good, got it set at 75 foot-pounds. Check the bore. I'm getting about 27/10 of an inch for clearance, so not 2000s, not 3, so it's about 2.7 thou, so 27/10 thou bearing clearance. It's a little looser than I thought, but it'll still be okay. It's better to be a little looser and a little tighter. I'm running a high volume, high pressure oil pump anyhow, so shouldn't be a problem. So next thing we do is put some piston rings together, mount them on piston 1, 3, 5, 7, and put them in the bore. So I'm going to start installing my piston rings, and you got to make sure you clock everything correctly. So the first one is the bottom oil support rail, which is pointing in this direction, and then the expander with the expander ring gap to the top. Actually, I should have started with that first because it's easier to get on, so I'll take this off. Put my expander directly at 12 o'clock. This is the number 1 piston. Then the bottom rail. Bottom support rail should be pointed at about 7 o'clock. My top rail, which should be around 10 o'clock. The other one should be about 8 o'clock. This should be about 10 o'clock. All right, up there. So the top oil ring gap is here, bottom ring gap is there. My expander gap is at 12 o'clock. These are recommendations by Total Seal because these are Total Seal rings that came with the diamond pistons. Second ring should go at 6 o'clock, obviously facing up. And the top ring should face 12 o'clock. So I'm gonna go like this. Like that. So top ring's 12, second ring is 6. Right there. Well, expander ring gap is 12 o'clock. 10 o'clock for the top oil support ring, and 8 o'clock for the lower support ring. And the expander gap, like I said, is at 12 o'clock. So that's how they're going to be orientated, that being the front of the motor. So I will go ahead and do the other three pistons for the left-hand side of the motor. So I'll do 1, 3, 5, 7 and do the whole bank at once, and then I'll go and install them. So pistons 1 through 7 all ready to be put in the bore. So I'm just doing a final cleanup using some good old ATF, Mercron, Dextron, non-synthetic transmission fluid. Just making sure there's no contamination, any gunk or grime that may have come in here while I was doing piston rings. On that note, I had to regrind the second piston rings once I got an email back from Total Seal. Diamond gave me a set of piston ring gaps that had the second ring quite a bit tighter than the top ring. After talking to Total Seal, and that's who makes the rings for diamond pistons, they suggested that I open up the bottom a couple thou, so I have a top ring gap of 30 to 31 and a lower ring gap of 29 to 30. So almost the same on the second ring and the top ring. So I opened them up a bit. They're pretty loose, but this is a blower motor that may see some nitrous here if I can't crank the boost enough, and I'm not happy. So I'm just future planning everything. So yeah, about 30 thou, 30 to 30, yeah, about 30 thou on the top, and about 29 to 30 on the bottom is kind of where they ended up being for ring gap. As per Total Seal's recommendations. He said I could have gone a little tighter. I might see a little bit of blow by, a little more than, but he also said it's not worth re-gapping because I got the wrong information from Diamond Piston Tech Support originally. And he says it's not worth replacing the rings. And I probably won't notice anything. So now that the cylinders are good, I'll put the first one in. And I have a nice taper ring compressor. So I'm just putting a little oil on that. So I got the crank throw all the way to the bottom, so it doesn't, no chance of nicking it. Just double check my rings here. Put a little bit of oil on the rings too. This is braking oil. Oil on the cylinder. This is a nice tapered ring compressor that I bought too, so should make driving these in pretty easy. Boom, just like that. Got a little plastic dowel for driving her in. I'll just push her down. There. And then I'm gonna put some assembly lube on the bottom. I'm actually gonna go up a bit. Put my cap on. Let's put my cap on hand tight. Move on to number 3. So now I'm going to do the other bank of pistons. I'm going to put the bearings in, clean them up really good. They're marked upper and lower, upper being the rod end, lower being the cap end. Have to orientate the piston rings differently because this is now on the other bank. So here we'll look at number 8 piston. So your top compression ring is actually now at 6 o'clock. Your second compression ring gap is at 12. Your oil expander ring gap is at around here, should be at 6 o'clock. Then your top oil ring rail gap should be at 10 o'clock, and your bottom oil ring gap should be at 2 o'clock. So a little bit different depending on which bank you're working on. So I'll clean these up, load them up, get everything ready. With Moly Lube, ARP Moly Lube for the fasteners. Load up my 4, 6, and 8 because I already did number 2 off camera. and install those in the other bank. So now that the pistons are all in, everything went good. Tapered ring compressor is probably the best money you can spend when building a motor for tools. So I'm just gonna start torquing up the rod bolts, which have to go to 75 foot-pounds. And I'm gonna check the bolt stretch. So now that the rod bolts are torqued, I gotta double check my bolt stretch. It's kind of hard to see, show the camera, but I got right around 6.5 thou, 6 to 6.5 thou. So that's right where I want to be for bolt stretch, which works out to 75 foot-pounds with ARP lube on these ARP 2000 studs. So I'm happy with that. So not under torqued or over torqued. Last thing I'm going to do is mount the dial indicator and check rod side thrust, basically rod clearance, making sure that I have enough side-to-side rod clearance in between. You can use a feeler gauge, but I'm going to set up a dial indicator just to see if I can be a little more accurate. So here's last check I'm going to do on the short block. And the short block assembly will be complete. I have the dial indicator set up and zeroed out. And I misspoke earlier, what I want is between 15 and 25 thou for rod clearance. At least 15. OEM's like 15 to 20. Performance builds are 15 to 25 thou. So I have, looks like 18 to 19. See if we can get a better angle on that. Try to zero that out. It's right around 18 thou rod clearance. Take in mind I got some assembly lube that's going to take a little bit of slack in there, so it's probably like maybe another thou. So about 18 thou. So that's all good. So last thing I'm going to do is mark all my caps for with pen mark that it's all torqued, and then the short block assembly is done. Well, that's a wrap for the short block assembly. Cranks in, pistons. Piston rings are all fouled to fit for the cylinder. I ended up with about 31 thou top and 28 to 30 for the second ring. Oil rings are all good. It's kept pretty aggressive, but should be able to handle any of the future mods that I want to do. And if I really want to turn up the boost, I talked to Total Seal about it. These are Total Seal rings on diamond pistons, and those are the numbers they recommended for my application. So everything's good. Pistons went in good. Clearance for the rods and everything good. Side load is all good. So she's all done, and should be rated for everything in the short block. Should be rated for about 1,500 horse now, crank horse. So should be a stout bottom end for anything I need to throw at it for the time being. So next video, I'm going to be doing the camshaft and heads, checking valve clearance, putting in the Johnson lifters, putting on the Lingenfelter ported heads, and finishing up the long block. So that's a wrap for this one. Thanks for watching, and we'll catch you next time.